Hello and welcome. In this video, we will cover implicit differentiation. First, we'll just go over what implicit differentiation is and cover some basic examples. Then we'll cover product rule, quotient rule, and chain rule, all using implicit differentiation. Feel free to skip ahead to those using the time codes in the description. Now, what is implicit differentiation? Normally, when we take a derivative, we have an equation such as this, where we can isolate for y, and it's equal to some function of x on the right. And then we can take the derivative normally, where we will have dy dx is equal to the derivative of the function on the right. And so implicit differentiation comes into play when we have an equation such as, let's say this. Where we can't just simply isolate this equation to have y equals some function of x where all the x's are on the right. So this is where implicit differentiation is going to come into play. Let's say that we just have x squared. When we take the derivative of x squared, so here we're taking the derivative of x squared with respect to x. And using the power rule, what we get is we will get 2x, and then what we normally don't write is that we kind of say this: we took the derivative of x with respect to x. And now, if we just look at this as a fraction, we have the same thing on top of the fraction as we do the bottom. So this is just going to simplify to 1. So we're just left with 2x. So normally, we don't show this step. But now, for instance, let's say that we have y squared, and we want to take the derivative of y squared with respect to x. We follow the exact same power rule, and we'll be left with 2y dy dx, because we took the derivative of y with respect to x. And this is kind of where the dy dx comes from. Because normally when we have an equation, let's say we have y is equal to x squared, and we take the derivative, we just jump right to writing dy dx is equal to 2x. And how we're going to want to start thinking about this when we do implicit differentiation is, say we have the same equation, but now what we're going to do is we're going to take the derivative of both sides with respect to x. So you're going to go d dx of y is equal to d dx of x squared. And now we just carry through with the steps. So on the left here with the normal power rule, the derivative of y is just going to be 1. So we're left with 1, and we took the derivative of y with respect to x, and then on the right we have 2x, and we took the derivative of x with respect to x. And now if we simplify this up, we don't have to write the 1. We're left with dy dx is equal to 2x, where again dx simplifies to 1. And so this is kind of the principle of implicit differentiation, where basically we just follow this step where we take the derivative of both sides, and then we just see how that unfolds. Simplify our dx, and then we isolate for dy dx. So let's jump into some more examples here. Now in this example, this is our equation, and we could, if we wanted to, isolate for y and then take the derivative normally. But in this case, we're going to use implicit differentiation. So the first step is we're going to rewrite as we're taking the derivative of each side with respect to x. And then now we simply follow this through. So in this first one, I'm going to write out every single step. So now we can just simply break up this derivative. So we'll have the derivative with respect to x of 3x plus the derivative with respect to x of 2y is equal to the derivative with respect to x of 5. And so on the left here, we know that using the power rule, the derivative of 3x is going to be 3 dx, where again we took the derivative of x with respect to x. Then here, the derivative of 2y, again we just use the power rule, but now we're looking at y. So we're going to be left with 2 dy dx, where we took the derivative of y with respect to x. And then on the right, the derivative of any constant is going to be 0. Now, we simplify the dx to 1, so we'll have 3 plus 2 dy dx equal to 0. And now we can simply isolate for dy dx. So we move the 3 over, we'll have 2. dy dx is equal to negative 3. Divide both sides by 2, and we will be left with dy dx is equal to negative 3 over 2. And this is our solution for the first question. Now in this question, again, if we wanted to, we could use algebra and isolate for y, and then take the derivative normally, but we're not, and we're going to use implicit differentiation. So again, first step, we're going to take the derivative of both sides with respect to x. Awesome. And now again for this one, I'll write it out again as we're going to split up this derivative. Okay, and now we just evaluate each derivative. So here the derivative of 4y, we're just again power rule, so we will be left with 4 dy by dx. And then here, the derivative of 3x squared, using the power rule, the 2 is going to multiply the 3. We will have 6x, and then we took the derivative of x with respect to x. And on the right side, the derivative of x is just going to be 1, and then dx, because we took the derivative of x with respect to x. And so this is what we're left with. Now we can simplify up our dx. So we have 4 dy by dx minus 6x is equal to 1. And now we just isolate for dy dx. So we have 4 dy dx is equal to 1 plus 6x. Divide each side by 4. And we're left with dy by dx is equal to, let's write it as 6x plus 1 over 4. And there we have it, we're done. Now again, we're going to start off this question by taking the derivative of each side with respect to x. And now I'm not going to write out each time, like I'm not going to break this up each time into writing d with dx of each. We can just start seeing that that's exactly what we're going to do as we go along. So first, let's take the derivative of x squared with respect to x. We will have 2x dx by dx. The derivative of minus 4y squared is going to give us minus 8y, where we took the derivative of y with respect to x. The derivative of minus 9 is the derivative of a constant, which is going to be 0. And then on the right side, derivative of 0 is just 0. So now we can simplify this up again. We have 2x, where that dx simplifies to 1, minus 8y dy by dx is equal to 0. Now we simply isolate for dy dx. So we move this negative 8y dy dx over, and I'm just going to write that on the left here, is equal to 2x. Now we can divide out the 8y. And we are going to be left with dy by dx is equal to x over 4y. And here's our final answer. Starting off this example, again, we're going to take the derivative of each side with respect to x. And then now we just go along and evaluate these. So the derivative of y to the 5 using the power rule is going to be 5 y to the 4, where we took the derivative of y with respect to x. Then on the right side, the derivative of x squared with respect to x is going to be 2x dx by dx. And then the derivative of minus 1 is just going to be 0 as it's a constant. Now we simplify, where our dx simplifies to 1. And then now here we can divide out the 5y to the 4, where we will be left with dy by dx is equal to 2x over 5y to the 4. Starting off this question like we did all the others, take the derivative of each side with respect to x. And now we go through and evaluate these. The derivative of y squared with respect to x is going to be 2y dy dx. The derivative of y with respect to x is going to be 1. So we just have dy dx. Now on the right side, the derivative of x squared with respect to x, 2x dx dx. And the derivative of negative 4 is a constant, which is going to be 0. And so now we'll just simplify this up here, where the dx simplifies to 1. And now we need to solve for dy dx, and we could see this is a common term. If we think about how we have a 1 here times the dy dx, we can factor out the common term dy dx as if it's just a normal variable in algebra. So we're left with 2y plus 1, where again we could see if we FOIL this back in, we'll get back to the step we have previous. And then this is equal to 2x. And now we simply just divide by 2y plus 1, where we have this cancel. And then we are left with our final answer. Dy dx is equal to 2x over 2y plus 1. And there we have it. Okay, and in this last example of the normal equations, we'll start by taking the derivative of each side with respect to x as always. And now we go through and evaluate this. The derivative of 2y cubed is going to be 6y squared dy by dx. The derivative of minus y is going to be negative 1 dy dx. Then on the right side, the derivative of 7 is going to be 0, which we don't have to write. And the derivative of minus x to the 4 is going to be minus 4x cubed dx dx, where the dx simplifies to 1. Now again, we could factor out our common term of dy dx, look at it just as another variable in algebra. So we factor out the dy by dx, and we're going to have 6y squared minus 1 equal to minus 4x cubed. Now here we can divide by 6y squared minus 1 on each side to isolate for our dy dx, where we will have dy by dx is equal to minus 4x cubed all over 6y squared minus 1. And this here is our final answer. Now we're going to jump into using product rule with implicit differentiation. So one term that we're likely to run into would be something along the lines of x squared multiplied by y, where if we want to take the derivative of this with respect to x, what we have to do is look at this just as the product rule, where let's say that our first term is x squared and our second term is going to be y. So if we remember product rule, what we're going to have is the derivative of the first times the second plus the derivative of the second times the first, or vice versa. And so evaluating this, what we're going to have is, if we take the derivative of the first term, we can write out all our steps the first time here. And so we'll have dx of x squared multiplied by the second term plus the derivative of the second term multiplied by the first term. And then if we go through and evaluate this, the derivative of x squared is going to be 2x dx dx, again where we took the derivative of x with respect to x, then the y stays there, plus the derivative of y with respect to x is just 1 times dy dx, and then our x squared. And the only thing left to do here is simplify our dx dx, which simplifies to 1. So we'll have 2xy plus dy dx x squared. And so that's our final term in this case. And so this is how we use the product rule with implicit differentiation. So let's jump into some examples like this. So here's an example where we can see that we're going to be using the product rule in the middle here. So we start this question off just like we did all the other implicit differentiation, where we start by taking the derivative of each side with respect to x. And once you get more comfortable with this, you don't need to write this step every single time. But if you want kind of a foolproof method of walking through questions, I advise you to do this until you really solidly understand what's going on. So again, now we just go through and take the derivative each time. So the derivative of y with respect to x, we're going to have dy by dx. And now we're going to apply the product rule here, where let's say our u is the x and our v is the y. So let's say the derivative let's take the derivative of the first term, so we can leave the 3 out front. We're going to take the derivative with respect to x of x, and then we're going to just multiply that by the y, and then we're going to add, we'll leave the 3 out front again. So we did the derivative of the first term multiplied by the second term, and we'll do the derivative of the second term multiplied by the first term, x. And then the derivative of -4 is just a constant, so we don't need that. And then the derivative of 0 on the other side is just 0. And now let's go through and actually execute these derivatives. Dy by dx plus the derivative of x with respect to x is going to be just dx by dx, which we can simplify as 1. And then don't forget the y. And then here we have 3. The derivative of y with respect to x is dy dx. Just going to write that out a little bit neater. 3 multiplied by x, which is going to be equal to 0. And so now let's move this 3y over to the other side. And I'm just going to move this dy dx here to the back of this expression. So I'm going to have 3x dy by dx is equal to negative 3y. And now here we can see again that we can factor out the dy's. So we'll have 1 plus 3x is equal to minus 3y. And then now we can just take this whole bracket, move it over to the other side. So we will have dy by dx is equal to minus 3y over 1 plus 3x. Or this is our final expression. So this is another example where we see we're going to be using the product rule. So let's start this out again by taking the derivative of each side with respect to x. And now we go through and evaluate these. So here is the product rule. So first let's take the derivative of the first term with respect to x. So let's just do that right away. Try to skip a couple steps. So the derivative of x with respect to x is just going to be dx by dx multiplied by the second term plus the derivative of the second term, which is going to be 3y squared dy dx, where we took the derivative of y with respect to x multiplied by the first term. And then the derivative of 3y is going to be 3 dy dx. And the derivative of x squared with respect to x is going to be 2x dx by dx. And now on the right side, 2 pi squared is just a constant. So the derivative of any constant is 0. We'll be left with 0. Let's go through and just simplify our dx dx. We have y cubed plus, and here I'm just going to move the dy dx to the back. So we'll have 3x y squared, and I just changed the order of this to lowest power to highest. And don't forget the dy dx at the back, plus 3 dy dx plus 2x is equal to 0. So now we want to isolate for our dy dx. So let's move our y cubed and 2x to the other side. And we will have 3x y squared dy dx plus 3 dy dx is equal to minus y cubed minus 2x. Now we can factor out a dy dx, and we will be left with 3x y squared plus 3 is equal to minus y cubed minus 2x. And now we can move this to the bottom on the other side, and we will be left with dy dx is equal to minus y cubed minus 2x over 3x y squared plus 3. Here is the final answer. Now let's move on to quotient rule, and we'll see how implicit differentiation is applied here. So say we have something of the sorts of 1 over x, y, and we want to differentiate this with respect to x. And so now, the saying we use for quotient rule, or I like to say, is the low d high minus high d low, square the bottom and throw it below. So we have low multiplied by d high minus high multiplied by d low, square the bottom and throw it below. So if we want to do this one here, low multiplied by our d high, which is the derivative of 1, minus high, which is 1, multiplied by the derivative of the low, and then we square the bottom and throw it below. And so we'll rewrite this out again, simplifying some stuff here. So we will have x, y, the derivative of a constant is just 0, and then we minus the derivative of xy. And so now here, this is actually going to be the product rule as well. And then all over the bottom squared. And this term here is multiplied by 0, and it's going to go to 0. So that's how we apply the quotient rule. And now let's just carry this through and get some extra practice with the product rule. So now, if we look at this, let's execute this here where we have minus. Let's put a bracket and just execute this derivative. So now we have the derivative of the first term, which is just going to be dx dx multiplied by the second term plus the derivative of the second term, dy by dx, multiplied by the first term. It's going to be x. And then that's all over xy all squared. So now let's simplify this out. And we're just going to bring this negative in as we do it. So dx dx simplifies to 1. We're going to have minus y. And then we're going to have minus, we'll just bring this x to the front of this expression. So we have x dy by dx. And then that is all over xy all squared. And that's our final answer. Now looking at this example, we can clearly see that we're going to have to use the quotient rule with the fraction on the right. So we'll start this as every other example by taking the derivative of each side with respect to x. And we just carry this through. So the derivative of x squared with respect to x is going to give us 2x dx dx. Now on the right, we use quotient rule. Low d high minus high d low. Square the bottom, throw it below. So we have our low d high minus our high d low square the bottom, throw it below. And now we just have to carefully walk through this and evaluate everything. So on the left, our dx dx simplifies to 1. We will have 2x. Then starting on the right here, x plus y. Then our derivative of x with respect to x is going to give us dx by dx minus the derivative of y with respect to x, dy by dx. Then over here, we'll do the same thing here now. The derivative of x with respect to x is going to give us dx dx. The derivative of y with respect to x is going to give us dy by dx. And again, this is all over x plus y all squared. Now, what I'm going to do here is I'm going to take this bottom portion over to the right side and kind of expand it out. So I'm going to keep the 2x that we have there, and then expanding this, we'll be left with x squared plus 2xy plus y squared. And now on this side, simplify this dx to 1. Same thing over here with this dx, we'll simplify it to 1. And now we can start foiling this in here. And so I'm going to write this one. I'm going to take this x plus y, multiply it by the 1. So I will have x plus y, and then I'm going to have minus dy by dx, which is going to be multiplied by that x plus y as well. And I'm just going to keep it like that because we're going to have to factor out the dy dx in a bit. And then on this side, I'll do the same where I have the minus. And then if I take this x minus y, multiply it by the 1, we're going to have x minus y. And then we will have this x minus y multiplied by the dy. So we'll have plus dy by dx multiplied by dx minus y. We're kind of getting overwhelmed with brackets, but that's okay. And now we'll go through on this side and FOIL this out here. So 2x by x squared will give us 2x cubed. 2x by 2xy will give us 4x squared y. Then 2x by y squared will give us 2x y squared. Now on the right, we just kind of carry along. We rewrite x plus y, and then here I'm just going to keep this minus there. Just keep the first part the same. Dy dx x plus y. And now here I'm going to just kind of FOIL in this minus. So if I bring this into the first x, we will have minus x. If I bring this into the minus y, plus y. And then I can bring this into this last term here, which is the dy dx, and we'll have minus dy by dx x minus y. And we have one cancellation here, which this positive x cancels out with this minus x. And then we could see that this y will be added with this y to make 2y. And we'll bring that 2y over to the other side. So we will have 2x cubed plus 4x squared y plus 2x y squared. Then where we bring these blue y's over, minus 2y is equal to, now we'll be looking at all we have left on this side are these dy dx terms. So let's factor out a minus dy dx. And we will be left with x plus y plus x minus y. And now we can see in here that these y's are going to cancel, and then we'll be left with 2x inside here. So I'm just going to simplify this up. As 2x. Now we can multiply each side by minus 1 to get rid of this negative. And now I'm just going to switch the sides. So I'm going to write dy by dx multiplied by 2x is equal to negative 2x cubed minus 4x squared y minus 2xy squared plus 2y, where now the last step is to divide by 2x on each side, where we can see that all these terms on the right can be divided by 2. And then we will be left with the final answer. And that there is our final answer. And now we're going to finish off with chain rule. So again, just a review of chain rule is say that we have some function of x and y that we say is u to some power n, and we want to take the derivative of this function with respect to x. What we will have is multiply by the power, we keep what's inside, minus 1 to the exponent, and then we take the derivative with respect to x of what's inside. And so now in this case, this is just going to be implicit differentiation. So let's see how this works in a couple examples. Now we start off by taking the derivative of each side with respect to x, always. And now we just step through this whole process. So here, this is going to be our first chain rule. So what we're going to do is we bring the exponent down front where we have 4. We keep what's inside, 2y minus x. We minus 1 from the exponent, so we're going to be left with 3. And then we're going to take the derivative of what's inside with respect to x. So it'll be 2y minus x. And I'm just going to leave this like that for now and do it on the next step. And then we continue over with the derivative up here. So the derivative of x squared is going to be 2x dx by dx. And on the right, we have the derivative of y with respect to x. We're going to get dy by dx. And then, of course, the derivative of 3 is 0. Now we're going to walk through this bottom part. So we have 4, 2y minus x cubed. And now we're going to be multiplying this all by this derivative here. So again, we just kind of FOIL in this derivative as we've been doing. So the derivative of 2y is going to be 2 dy by dx minus the derivative of x is going to be dx by dx, which we know now is just 1. And then we're going to be adding 2 dx dx. Again, this simplifies to 1. So we're going to have 2x is equal to dy by dx. And now we need to isolate for our dy dx. So unfortunately, we're going to have to FOIL this part into this equation. So first, let's just do it one step at a time. And let's FOIL this 4 in. So we will have 2y minus x cubed multiplied by 8 dy by dx minus 4 plus, and over here I'm going to save one step by moving this dx and dy over, and the 2x we're going to minus dy by dx is equal to minus 2x. And now we're going to have to FOIL this in, so we will have 8 dy by dx multiplied by 2y minus x cubed. Then we FOIL this over to the 4 minus 4 2y minus x cubed. minus dy by dx is equal to minus 2x. And so now this term has dx and this term, so we're going to leave them, and we're going to move this term over to the other side. So we're going to have 8 dy dx 2y minus x cubed. Then this guy, minus dy dx is going to equal 4 2y minus x cubed minus 2x. Now we can factor out this dy dx, where we will have dy dx of, just going to make this a big square bracket, 8 2y minus x cubed minus 1. This is going to be equal to same thing on the right. And now we just have to divide by this. It's going to be 8. And then same thing all over here. Where of course this will then cancel with this, and we'll be left with dy by dx is equal to minus 2x all over 8 2y minus x cubed minus 1. And this is the final answer. And as we can see from this, it's just a lot of steps and a lot of algebra, but the process is the exact same as your normal chain rule. And this here will be the last example on chain rule. So we start out by taking the derivative with respect to x of each side. I'm actually going to make this a square bracket. And now we just have to go through and evaluate this every time. So first, we're going to have chain rule on this first term. And so how we're going to do this is we'll have the 2, the 3 will come down. So that will make it 6. We keep what's inside. Minus 1 from the exponent. And then we'll take the derivative with respect to x of what's inside. So of x squared plus 1. And that's this first one here done. And now on to the second one. So now what we will have is the exponent comes down, 2, keep what's inside, and then we take the derivative of what's inside. And there you go, that one's done. And now on the right, the derivative of constant is 0. Now let's go through and actually evaluate these derivatives here. And so we're going to have 6 x cubed plus 1 squared, and this could be multiplied by 2x dx plus 0, because the derivative, where we did the x squared, and then the derivative of the 1 is 0. So I'm just going to simplify this up right here as just 2x, and then we're going to have plus, I'm going to factor in this 2 right away here, so we're going to have 2y squared plus 2, and now this derivative, we're going to have 2y dy dx plus 0, which is the derivative of the constant there. So I'm just going to write this as such. Now here, I'm just going to simplify this here. So if we take the 6 into the 2x, that's going to give us 12x multiplied by x cubed plus 1, which is squared. And then here, I'm going to FOIL in the 2y and keep the dy dx out front. So you're going to have dy dx. It's multiplied by, it's going to be 4y cubed plus 4y is equal to 0. I'm going to move this over to the other side. So on this side, I'll have dy dx, which is 4y cubed plus 4y, which is equal to negative 12x, x cubed plus 1 all squared. And now we can divide by 4y cubed plus 4y to get the final answer. Where this is going to cancel out. We'll be left with and on the bottom here, we can factor out a 4. Could also factor out a y, but I don't think it'll make too much of a difference. And then we can simplify this fraction here. So the 4 and the 12 will give us 3. And this here is the final answer. Thanks very much for watching. I hope this was helpful. If you have any ideas for future videos, please leave a comment. And if you found this helpful, please give it a thumbs up. Best of luck in your math classes. See you in the next video.